because the.
I mean, we're very lean. There's like
and there's a big like scientific Python community in town.
Good problem to have, I guess.
Yeah.
How big is how big do they get?
Like,
so I'm new to the
they
whole.
like fill the other side.
Yeah.
Okay.
For sure. Yeah, check
It's
us out.
probably. I mean, it kind of depends on the talk and the month and the,
Yeah.
you know, whatever. But they probably get like 80 people or something.
Really?
Yeah.
At the actual meetups as well, not just like RSVPs.
Yeah, I think so. Yeah.
Nice.
I haven't been to one in a while, so
Okay.
I haven't asked them like what the attendance is like. Which ones lately? The co-founder of uStudio runs Alpha, the web Python meetup.
Oh, okay.
And then
Yeah.
they're affiliated with
Yeah,
awesome
definitely. I'm not a
Python user
developer, I'm
group.
technical in that market.
Just generic Python.
So, like, I mean, I specialize in like SEO and analytics and all that, but.
Scott.
Yeah, so that's cool. Yeah, bro. But yeah, I definitely get you.
Is there a Slack channel for this group?
No, but that's something we can make. So I'm taking, this is my first meetup, but taking suggestions. So we need a Twitter.
Out of the community, so, yeah, we could probably have one added to the Kubernetes Slack, would be pretty straightforward.
Yeah.
Not necessarily,
We can do that actually. All right.
Try to make a template. Yes, so for hashtag.
Storming hashtags here.
Just be cat, KTX.
KTX?
I don't know, K or K8TX.
KTX maybe?
Is there no radio station that's KATX? That was like a no-brainer.
K8? K8S?
Oh, yeah,
TX?
when we did the OpenStack one, it was during the Occupy, and so OSATX was Occupy San Antonio. And we would cross the Camden with their every couple of weeks, we'd cross the Camden.
That's fun.
It was pretty funny.
You do, man. Matt Harvard, right? Nice to meet you. Thanks for coming.
Actually, we're the first in Texas, we just claimed KATX.
I'm Lamb.
Matt Harvard, nice to meet you.
Yeah.
Cheers.
Thank you for starting this group.
Yeah, absolutely. Yeah.
Hey, sure.
Matt Harvard, nice to meet you, Adam.
Yeah, you do.
Huh.
Yeah.
No, I think KATX is probably.
Mark Love. Mark, nice to meet you, Mark. Cheers.
Oh, there's no pizza.
As much fun as it is to be clever, you sort of want to just keep it where people would guess.
Be simple.
Like,
Yeah.
with, so this is. Okay, 8ATX like that.
I like that. Any clever hashtags, guys, or
I think you need an S.
simple ones? Yeah, Kubernetes. That has right here.
Yes, there you go.
Would that be more obvious? All right.
Yeah.
That would be intuitive.
Yep.
Damn intuitive. All right.
Any other suggestions, guys? We got one. That'll work.
That one's, if you're going for the, like, what people don't have to think about or remember, that one's it.
Anybody doing the music festival this weekend here, or ACL?
It's all sold out, isn't it?
Yeah, I think so.
Both weekends?
It's pretty easy to get.
Yeah, you can still get tickets. Well, they're just expensive, man. It's like, I think if you get them, base price is like $250, which is,
Wow.
it's a lot of money, and then you add food and alcohol, if that's your thing, you know, it's, you're looking at a very expensive weekend, so.
Did they ever get to the single day tickets, or did they sell out on the, I wasn't watching.
I think if you go out, I think they sold out on them, but if you just go and walk that street, they'll sell them for like $100. That's usually
For single days.
if I try to go for a day, that's what I'll do. 3 days, it's a young man's game, you know?
I used to get them through.
You can
work.
pick and choose there.
Yeah.
Good, nice
Work.
discount through. Yeah, because I used to work for AMD, which was one of the main.
Oh, nice, yeah.
There was a nice discount, but
Yeah, they got the AMD stage. Yeah.
I don't know if they still do.
I think they did last year.
Yeah.
In the last few years, yeah.
I quit, so.
Yeah, I think I'm actually gonna go, but the only reason is because I have friends coming to town.
Yeah.
If they weren't coming to town, I'd definitely not be going. I'd be relaxing this weekend. Yeah.
I live close enough, I can just like stand on my balcony and listen to it.
Really?
So, yeah.
That's cool.
Pretty
Yeah,
close.
he's around there too. Yeah.
Well, it's cool sometimes, and it's less cool sometimes.
Well, good news is it's over at 10, so
Yeah.
it's not too late to
Yeah.
where like you're just like turn off the music,
Yeah.
you know.
That's why it ends at 10, it's
Yeah.
just like living in the green, it's like.
Well, Fun Fest is like closer to me, so that's worse. That's like sitting in the house and I'm like, yep, I know what that band is, like.
Yeah. Yeah. So you're at are you out there across from Zoker then I take it?
No, I'm a little, like, I'm closer to, like, auditorium shows.
Oh, okay. Yeah, I got you. I've never actually been to Fun Fest, but here it's a good time.
Is there an access code for the Wi-Fi?
Let me get that for you.
Mostly just to make this pop up go away.
I think it might just be the factory, but I can't remember.
That card out front for the Wi-Fi code?
All right, I'll go grab one. Thanks.
Yeah.
How far are people coming? So
I live
curiosity.
pretty close.
You live close?
I actually came from Temple, Bell County.
Did you really? Nice. Okay. You come into Austin often, or?
Yeah, I used to live here and we just moved.
Okay.
Yeah.
Yeah,
So I work
So you work by here?
I did today, I work remotely, but today we have that space in the real tight.
We have trouble now. Chris?
Some people stuff, they're like, what? I think there's just so much. It's hard to have them on, so it's nice that.
Yeah, it's always, it's funny, because it lives so close, but you don't usually truck downtown to.
I live in Cherrywood, I guess, but I only moved here like a month ago, so just started working up here.
It was just kinda cool that it was this other thing.
I moved into town, it was just a bit.
So I've never used it.
From Northwest Arkansas, and I work for a hosted Elasticsearch service, and we just released a new open source Kubernetes service as well.
I work at
Called
Giant, so
I saw this, I saw the text.
Yeah.
So it's a hosted Kubernetes service?
No, so that's a hosted Elasticsearch service, and we built a Kubernetes product to solve our own problems, and then we open sourced it. Okay. And, it's, there's a lot of useful components, and so we abstracted a bunch of layers, makes it a lot easier to deploy a bunch of different things, and then, we have a packing algorithm that cuts down on AWS costs. Right now, we're still.
Oh, do you really?
Yeah, so you guys been around for years.
Like, I would've brought some, but they just went out that.
Oh, yeah.
ABC guy, I was like, yeah, I'm not trying to hire somebody.
So does that, do you deploy Elasticsearch in Kubernetes too? or-
So that is one of our first, like, kind of revenue models. Yes, we do. And you can actually, if you have Elasticsearch, you can just use our service. But once you get a certain kind of, size of the company, it almost makes sense to internalize. And so then we'll try to get our existing, like, bigger customers to move straight into Supergiant, and then we sell them a software contract or something like that. But that's still way more than most people. As far as like the Elasticsearch thing.
Yeah.
Yeah, that's cool.
Interesting model.
I remember looking.
It's a new thing, I've never worked for, open source, so it's a very different kind of angle as far as all that goes too, but.
Yeah.
It's a lot more fun, a lot more community involved and all that.
I just my second one to go to.
Just trying to network. But.
Yeah, basically anything you want to have this
Yeah, I've been doing open source for a while, and it's a good thing, although revenue models are still I don't think anybody thinks about it.
Yeah.
That's why, I really love Docker, and then ended up coming to that Docker meetup.
Interesting. I'm starting to meet more ISVs who are building their platforms on top of Kubernetes. So, do you know what the rationale was, why they chose Kubernetes as the?
I think honestly, like our lead engineers just thought that it was probably the most elegant solution to everything. And then the problem is that it's still such an emerging technology. There's so many things you gotta learn to be really good at it. And most like DevOps, sysadmin guys don't have the kind of time that they need to get super efficient, especially when they're trying to stop this. And so that was what we were initially trying to solve. And then besides that, we had that basic which was our packing algorithm. So,
Hey, what's up?
well, not to sound too spammy, but I mean, check us out. We haven't, I think we've got one, so it's contract so far. Like right now, our newsletter is still Xerox, which is our Elasticsearch.
So we're using JavaScript.
We're looking for contributors.
Is it like that distributed as a Kubernetes manifest?
It's distributed apps.
Right, but you would take Kubernetes infrastructure and then you have a manifest that you would distribute.
And so it's really up to you. We don't, you can use anything in Kubernetes, and then you can run Supercharge as well. Or you can just use our own interface. Use the CLI, you use our.
Yep.
I guess so the Supergiant Kubernetes, are you deploying Kubernetes or are you?
What I mean, which is saw it. I don't know where you saw it. Maybe like just meetup.com. I know eventually I got into it.
So I guess the app is running in Kubernetes.
It's like, hey, you've got this.
So if you're a Go wrapper around, and we just modify it, but that's just like.
Because we're like, we've got a.
Like we also have.
Especially with,
interfaces that you can do all the other stuff. Just have that. And I mean, honestly, like you should probably talk about it. I'm glad I'm here every day, but I'm glad to try to get everyone stuff. It's like channel and let them talk.
So are you a community
Yeah.
management?
But
You know process, right? You're like.
I'm basically a technical about.
Yeah, like
I know about this much of Python.
Zilker's like, this is the river and then there's downtown, Zilker's here and I'm like over here.
We also like write blogs and all that stuff. So I have to do all that, so.
For Mongo, yeah.
So I'm just here.
The Mongo driver.
I'm here to be here, but probably can't contribute a
That's the
whole
reason
lot.
to come out to the.
I'm starting to think about self-hosting. Do you guys host?
Maybe
You did it host your own. I just put hosting out there, sorry. I guess once you get on
I realized I forgot to set something up. That's my excuse.
No. Well, actually, yes. If you want to hear. They started.
Thank you, I appreciate the offer.
Things are good. Things are great.
I tried, like Kelly and I last time we did this, I tried like using the last CLI to create something like.
Yeah, no, things are good. There's a lot of drama going on behind the scenes right now.
It did something like slightly different than this, and it's just
I'm
like,
happy as long as.
like they just like, I just tried like creating a node with like a path, like all the way down to one node. And it like, something about the way it did it, like folders, the virtual folders didn't have IDs. So then when you did a list, it would show up like a zone entity.
Yeah, that
cool. It's really special.
Yeah.
Yeah, we're not gonna win that
This is
fight.
like, where's that
Working on it.
store, right?
Like if that middle school is down, you know.
And they're,
Yeah, I mean,
I
that's
think they're
what
fine
happened
with
to
you
had it around.
getting in a position where they, I think so.
Josh is watching.
Specifically for MongoDB, if it's clustered, the failure was
Yeah.
So I think the failure will find a fit in the market. It's fast agents. But yeah, I'm neither a Kubernetes expert nor ops, nor MongoDB expert. That's why I'm like,
I didn't see it, but no, but I was just like, I was in the thick of it, because that was so into
we're pretty mild, like, clear.
And I'm really worried about.
They fixed it, they changed the name of the project.
Swarm was the word, yeah, Swarm is the word, Well is the worst, it's the worst. They basically made everyone angry. That was the final straw.
No, it's, the idea that you're gonna add enough knowledge to use the tool. It's
Without even making it, like,
And I think that's the hardest part, is that
Google Cloud
Compile flag.
Too inclusive. Apparently we're the only one.
That's and that's what I did a nice assessment on, because I've been worrying about it, choose your brand and the engine, and then so the assessment. That's technical issues where you're getting more complexity into the stage where you can dock commercial, and we ran a
Yeah, I'm trying to work on
rapid ship your product, and all of a sudden our rapid.
it's gonna be interesting to happen, because the value is moving to the stack, and like, there's no idea the format, the registry is debatable.
So I was trying to, I was gonna do a demo, like, I just ended up with.
You could go to the store model where they're trying to. 23%.
But that's.
I have trying to like do a federated, like for, we'll see, I want to next month, most likely. Next thing coming in is basically distribution of registries. Federated. Registries.
People are gonna have their own machines, they're not, and
So-
there's way too much data flowing through the registry.
Yeah. So like, how do you make money with the value? Like, nobody really knows. It's just kind of like,
Classic fundraising, before pop raise too much, then you're like on a cliff.
It's gonna be interesting to see what happens. We're trying to do what's best for our, like, the guy for that.
Yeah,
That's what we're making,
Yeah.
money elsewhere, right? And stop. He recommended using Jackson Beach container.
I think I have.
Trying to change usage in the class, because I get all the time. That's a great question. How about his hell? And that's a kind of first entry point usually is like, oh, I have something that's like, business one. Where is that? I mean, just go out and say,
That's, I actually went, I'll spend a second to talk, actually, a lot of what we're gonna talk about is.
Okay.
And it's, so it's going out and,
Yeah.
but, we actually just publicized our.
Fred.
Yeah. Kubernetes, all these small units.
Okay.
But then we just.
Okay.
And then that lets you swap Rocket. You know, it's like, oh, here's a module where you install Docker, no other stuff, just that, just you can swap it. I'll show a little bit.
Yeah, no worries, I'm gonna go,
Hirschfeld. But, no, it's never happened
In
before.
front of the 60 members here.
Yeah. It-
Give it a couple more minutes, let maybe some more people trickle in. I mean, we said 60, so all 60 usually come to these things, right?
Something like that.
100% attendance rate? Yeah.
Pretty much like a promise. blood
Yeah,
oath.
like
Yeah.
if you don't come,
Yeah.
you can't come in the future, you know, it's a thing. So he's got, just a couple quick announcements, he's got parking validation out there for people, if you wanna grab that, he said it makes it probably from $20 to $5, so if you're into saving money, gentleman right at the front desk will help you out there. Our, I guess, I'll go ahead and kinda get started here, guys. My name's Matt Harbor, I'm with Apprenda. We're kinda sponsoring this event here, and thanks all of you for coming. I know everybody's busy, traffic was probably not too good coming here, so I do appreciate it.
I don't know, traffic was horrible.
Was it? I think probably with ACL, yeah.
ACL.
With ACL starting the music festival, yeah, I bet it was,
Like extra tourists. and
they should have
stuff.
taken into account that we were doing this meetup here, right?
Yeah, and there was a train crash in New York that probably trickled all the way down.
Yeah.
It was way worse than usual, so.
It's never good.
Right, yeah.
Big city though, so, thanks for coming, everybody. Before we get started, I know there's various people here that go to different meetup groups, so if there's any that you maybe want to promote or you've heard about that you've gone to that is pretty good, feel free to speak up and we can kind of write it on the board.
There's a Container Days is coming.
Yeah.
And if you're interested in any Kubernetes stuff, Containers is gonna be a huge event, so.
You said Container Day?
Container Days, I'm not sure the dates, but it's soon.
October 14 and 15. And for those willing to travel, KubeCon in Seattle is in November.
Election Day. I'll be there, I'll be at KubeCon.
Yeah, I will too.
You know the dates of KubeCon by chance?
14, no,
8 and
7,
9.
7, 8, 9.
7,
Well,
8,
there's
9.
open shifts.
Open shift
Commons
has a
gathering.
tree, and then there's some post events too.
Yeah.
There's a, if you're in there and you're willing to stay, there's a meetup. The Austin Kubernetes meetup is the next day.
Which day?
It's a Thursday, I think.
Oh.
Wednesday, no, it's Wednesday night. So
Wednesday.
the KubeCon, Tuesday, Wednesday night is the Seattle meetup.
Monday's the open shift.
Monday's the open shift, and then Developer Days is Thursday, which if you don't have, it's a very small event, so they have a lottery. I can,
I'd like to know. Right, book it.
Yeah. Good stuff. Anybody else?
Yeah, over the summer, we started Austin TensorFlow meetup, that's related to Kubernetes. It's officially Austin Deep Learning with the emphasis on TensorFlow, but.
Austin, what was it again?
Austin Deep Learning is the name of the meetup, but there's an emphasis on TensorFlow.
Okay. I'm gonna butcher the spelling of that, so I'm not gonna try. But yeah, when is there a specific meetup date, or do you guys have one coming up?
We just had one this past Tuesday, we're doing once a month. We've been doing it at the end of the month, we're trying to move it to the beginning of the month, so
Nice. Probably about a month.
early October.
Yeah, cool. So I think what we're gonna plan on doing for this one is every other month right now. So be on the lookout for probably one sometime in November. We're trying to lock down a date. And then if there's any interest, we could potentially do some type of happy hour in between. Maybe kind of middle downtown, whatever works for everybody. So just show of hands, are most people up north, down south, kind of a mix? Up north, Northsiders? Yep. South side, okay. Okay, so probably if we do something like that, we'll just keep it central like we're doing now. Yeah, central for everybody. We want everybody to hit the 5 o'clock traffic, so, yeah, 30, 45 minutes in.
Actually, there was another Kubernetes, I don't know if it's related that I went, it was hosted, I don't remember, but Google, at the Google facility, are you in touch with them at all?
So I'm not, but that's something
Because
that
I
I'll.
went to a different Kubernetes meetup.
Nice.
than
What,
this one,
it was
so-
when was that?
It was the birthday
2
party.
months ago?
It was the launch.
Oh, the birthday
Yeah.
party, okay.
It was part of a meetup though.
I think it was maybe the Docker meetup with the
Okay.
Kubernetes
They had
birthday.
a
GCP, Google Cloud Platform.
Yeah, maybe it was that. Yeah.
Okay, okay, fair enough. I'll look into it if it's something maybe we can kind of collaborate
Yeah,
together.
maybe you can get some other Google resource too if you want speakers or
Awesome, yeah.
They did the announcement of the features for 1.3, and now 1.4 is out.
Nice, and we'll be looking for speakers too, so if there's, I'm, just a little bit of background on me, I'm not technical whatsoever, just never claimed to be, I got a technical guy for me, but, we will be looking for speakers, so if that's something that you'd be interested in, just kind of feel free to ping me afterwards, we can talk after the meeting, so. But we do have two individuals today that have been generous enough to kind of step forward and be our speakers for the first one. I'll let you guys introduce them. That's Rob Hirschfield right here. And if maybe, Rob, you want to stand up and give a little bit of background on yourself
Sure.
before we get started.
So my name's Rob Hirschfield. I'm a startup founder for a company called RackN. We work on hybrid infrastructure automation, so what we usually call underlay, so helping people move metal, multi-cloud automation, things like that. And we've been working on Kubernetes for a long time, actually, and doing like Kubernetes installs and automation at the bottom side, so how do you get it installed and operational and things like that. So I also co-chair the Kubernetes cluster operations SIG, so Kubernetes broken into a whole bunch of SIGs. And my history runs towards the ops side of infrastructure, and so we're trying to get people who are running Kubernetes or talking about running Kubernetes to get together so that we actually have a voice in our community.
And then as well, Thomas Stevens right here.
Yeah. Hey, I work for uStudio, obviously. I'm a full stack developer. I've been there for about 3.5 years, been in Austin for longer than that. And we started using Kubernetes in production for some of our newer services, and we're really enjoying using it. It's really streamlined a lot of our development and deployment workflow. So I'm going to show kind of how we did it, what we built, and I'm also definitely interested in what other people built. So,
Yeah. Let's give a round of applause, huh?
And Matt, thank you for organizing.
Oh,
That's awesome.
yeah. I had a lot of help too, guys, so I did buy the drinks and the pizza, and really it wouldn't be anything without you guys coming, so I really do appreciate it. The other 60 are probably pouring in anything like that, so. I guess, Rob, if you want to go ahead and get connected here, we can go ahead and get started. I know you guys didn't come here to listen to me, so. And then we can get pretty interactive too, if there's questions, if we want to keep it going, you know, feel free.
So because I don't have any PowerPoint at all. I do have a whole bunch of working documents, and so we'll talk about those things. So my goal tonight, for the cluster ops SIG, I was on the OpenStack board for 4 years, and if you're familiar, how many of you are familiar with OpenStack? All right, so you all know that it's not well respected as an operational platform. And there was a whole bunch of operator revolts and things like that. And so our goal was to keep that from happening in Kubernetes. And so and thus organize. Yeah, I did that. And so organize operators early and start talking about operational concerns early. Kubernetes community is much more operator friendly. They really value the. I'm trying to get my display going. They really value ops, but even so, there's a ton of stuff going on that, if as an operator, so I've done a lot of my whole career has been sort of in this cloud operations and underlay space. Makes you scratch your head and you're like, guys, let's keep operators like things simple and transparent and really easy. You'll see my desktop? Yeah.
Yep.
All right, how many people here have actually run Kubernetes? How many of these do we see? And how many people know nothing about Kubernetes at all or minimal about Kubernetes? Okay, cool. Boy. So one of the things, besides this table is being tilty tippy, what I have on the screen is actually a base, there is nothing in it Kubernetes deployment running on Amazon that I installed a couple minutes ago. And to install something in Kubernetes, actually, this is not true. This is Kubernetes. Okay, so it is a RESTful, it's a set of services, we'll talk about what they are. and that's it. What I'm actually showing here
How
is
did you spool it up? Did you use like one of 3 methods that is supported by the Kubernetes IO?
So no, so the thing I do, I run an open source project called Digital Rebar, and Digital Rebar has a Kubernetes deployment. I'll run it in the background and you can see it, how it goes, and then we can talk about that too. There's a lot of different ways to install Kubernetes, and there's more surfacing, which is actually pretty typical for an open source project. The people who want a canonical way to install Kubernetes is, unless you want to buy it from Canonical, you're not going to find one, because different people's operational needs and different commercial pressures are going to drive us to have different ones. Our goal is to actually create something that's operationally pluggable, and that should become more obvious. So, yeah, you have a
I
question?
was gonna ask you, so obviously, if you don't deal with the operations, the easiest way is to do on a cloud platform, whether it's GKE or Amazon. But if you have restrictions and you have to manage your own Kubernetes infrastructure, there are several ways to install it, and if you have some, I mean, you mentioned yours, but they're talking also a project that uses Kubernetes itself to manage Kubernetes, other than the first 2 elements.
I'll actually talk about that. Yes.
Self-host, I don't know what they call it.
There's three.
Is he promising that? I'm just kind of curious.
So actually, that's my topic for tonight. Is I'm going to go through those 3 predominant ways that we deploy it, because what we've been doing in cluster ops is we've actually been trying to document that stuff for operators. So the goal for cluster ops is to actually create, besides forming a community, we're actually trying to create a deliverable, which is a document. So this is the all-in-one guest book. So just as I'll go a little bit out of order, but what this does is there's a YAML file, manifest file, that describes all of the components for this application. I uploaded that file to the dashboard, which is another Kubernetes application, and that's calling back into Kubernetes to spin up containers, wire them together, build networking. There's a ton of sort of magic that happens with Kubernetes, where it actually spins up containers, cross-references them, creates a space where the containers can talk to each other. So there's a significant amount of things that go on, and I'll actually decompose that because we're going to talk about what the underlays are for Kubernetes. Does that make sense? I'm seeing some. So that's an end product Kubernetes. To build Kubernetes the way we're doing it, this is not going to be that instructive, but because basically it's what we do is a point and click Kubernetes install. So once you've installed Digital Rebar on a server, you can pick. I'm just going through a normal Kubernetes deployment. It creates a manifest, effectively a manifest file, and I'm going to hit go, because I really don't want to spend a lot of time showing you the Digital Rebar stuff. You can go Google Digital Rebar and see videos and do stuff like that. The reason why this is important, though, I've already baked one deployment here for the Meetup, is that you end up with a whole bunch of components and parts and things that need to be done in order to build a Kubernetes infrastructure. Everything from getting servers, to getting Docker installed on those servers, to getting a public key infrastructure on those machines, to actually building the services and placing the services that go into that. So when you talk about what it takes to build Kubernetes, there's one API server, but there's a ton of pieces that go in behind the scenes for that. And what I just kicked off behind the scenes is, this is the one I did before the meeting, and my system's running a little pokey because it's on my cell modem. Oh, here it is. It's going to go through and build a new matrix of those services.
So is you call this Rebar?
This is Rebar.
Is this the equivalent of Fuel for OpenStack?
Yes, that would be probably a fair statement. In a lot of ways, that's what our goal is. The difference being that Metal, Cloud, right? Wherever you want to go, yeah.
When Google Cloud says we host a managed Kubernetes platform, is that kind of what Rebar is doing?
So no, we're not trying to be a SaaS. It's really a self-service thing. So you run, it's to run your Kubernetes on your own platform or Amazon, Google. So what Rebar is generic underlay.
Okay.
And so you could actually install Swarm or Mesos or OpenStack or Hadoop, whatever you were interested in doing. It'll prep the environment for you and then wire that in.
Okay. So instead of, like Rebar would be if I wanted to manage it instead of.
Right.
Okay, got it.
Right, and so the benefit of what I'm showing here is that it gives you visibility into the system, actually what components and what they're doing. And so usually when I'm talking to people, and this is where what I do in Kubernetes is a little bit different than people do on the front end, right? So there's a lot of people who can talk to you about how the API works, and how you upload an app, and how you transition containers and you deploy things into Kubernetes. From an operator side, I'm very worried about how you create an upgradable, stable, secure, multi-platform deployment of Kubernetes. And so that's what the cluster ops SIG has been doing, right? I have one approach to it, but there's other people who have different strategies. And so so the cluster ops SIG meets weekly on Thursdays at 3 o'clock Central Time, 1 p.m. Pacific. So you're welcome to join in, and we'll talk about that. We do demos, we work on the docs actually quite a bit. And so if you're trying to learn how all this stuff works, it's a good place to do it. We have decided to be very opinionated in that we are not building dev Kubernetes, we're not building wild hair Kubernetes, we're building standard production deployment Kubernetes, right? Where people say, oh, I'm going to dedicate 3 nodes to building an HA cluster, and that's, and somebody always shows up and says, yeah, but I could do this where I'm putting this thing on that and this on that, and you're like, plain vanilla, comprehensible Kubernetes, and then variations from there. But so what I'm going to show you tonight is building towards that plain vanilla, what everybody would argue is a boring, run-of-the-mill Kubernetes deployment, and then if you want to get into the fun of, but then I could, this will do it. So we have that meetings. If you're involved in Kubernetes, want to get involved, the community has a broad meeting every Thursday at noon. So you can join in on that and listen to release updates and SIG reports, special interest group reports. There's demos, short demos every couple of weeks. There's tons of stuff going on. So it's a huge meeting, like 100-something people attend every week. It's a really good way to sort of get the pulse of Kubernetes and then figure out if you have a specialty, then you can dive in on the SIGs.
Question?
Yeah.
How are the meetings on Hangouts, or how are they streamed?
So they're on Zoom. We're actually Cluster Ops is about to move to Zoom meetings from Hangouts. A lot of we're sort of mixed. There's a lot of Googlers, so they like Hangouts. But we've been moving to Zoom, and then they'll record the big Kubernetes ones are recorded. Actually, a lot of these meetings are recorded, and generally they all have note taking that goes in a Google Doc, and then they just add at the top. So they top post new meetings in that. So you can go to the community SIG and you can read all about what's been going on. And the note taking is surprisingly good. So the community does a really nice job using Google Docs to take notes and stuff like that. Makes sense. So this is the Cluster Ops meeting Word doc or Google Doc that we've been adding to forever. And so a lot of the links for the drawings I'm going to show you are based out of this. What we've been building towards is this document that's supposed to talk through how you install a Kubernetes cluster. So if you go to the docs, you will be less than excited about the Kubernetes documentation. For ops, actually the documentation for using Kubernetes is pretty good, but I'll handle this in Q&A, but there's a lot of migration in how we do Kubernetes. The Docker guys with Swarm came in and sort of did a shot across the bow, and a whole bunch of Kubernetes people are trying to do make things easier stuff. See really good. So if this is interesting to you, please come to the meetings, help us write the docs, help us do the drawings. The work I'm going to show you
is actually a consequence of, so this was the old drawings. Got out of date pretty fast, and it's not a chart, so I'm not gonna do it, but, so what we're trying to do is improve the docs. We got to a point with the docs where we realized we needed drawings. If the drawings were good, then the docs are simple, and that's what we've been doing. So we started, so I'll pause, yeah.
Question, you have documentation on how operators go in and set up a cluster in production that's production grade for Kubernetes, right? Is there automation to that? Are you working on the Ansible or whatever provisioning tool to automate that, or you just provide documentation on how you would manually go and set up a?
So we're, like, my company's working on automation for it.
Okay.
Different companies are working on different automation because they have different strategies on
Right.
how to do it. We're trying to document that. Somebody named Kelsey Hightower
Yeah, I know those.
wrote something called Kubernetes the Hard Way,
Yeah.
which is sort of become the Bible of a manual Kubernetes install. The title is
It's indicative.
well, it is. Actually, what we did was we looked at his stuff, we thought it was really good, and we automated that.
They don't have a lot of incentive to make it easy because they would want you to hopefully say, crap, I don't wanna deal with this, I'm gonna go on GCE, right, technically, right?
Oh, the Google people? No, the Google people, strategically, their big enemy is Amazon. And so if they make it easy to use Kubernetes, then you are much less platform locked than Amazon. And so they have everything to gain from that. So they
Even running on-prem technically is.
even on-prem, or if you run Kubernetes on Amazon, it's a benefit to
Yeah,
Google.
because they can easily.
Yeah, so that's as far as I would infer. I'm not at Google. That's the strategy. Yeah.
Could I ask just how difficult in general people would feel it would be to install Kubernetes from scratch? Just 'cause the company more or less said it's too complicated, we don't want to touch it, and that's why I'm here. I find that very odd. Or is it really that?
So Kubernetes, I mean, I install all sorts of stuff. Any multi-node system has complexity to it, and Kubernetes made what I think is a really good decision, which is they require you to use encrypted communications, which means that you have to roll a PKI or certificates in order to use it. And then the Go services are either going to run in containers or run in systemd. And so what you've got is, let me get to that.
Okay, sure.
It's a great question, and we'll come back to it. So here's what we did from an ops, because I want to be careful and also leave time, brother. So here's what we did. We said, look, there's actually an OSI layer. We're trying to make this comprehensible so that I can present this in 10 minutes, and you'll go, I now understand how Kubernetes works. So there's a stack of things that you need to do. Not all of them are Kubernetes. So you need to get nodes in a ready state. You need to install the prerequisites. You actually have to have some cluster services. So we'll talk about those are the actual Kubernetes things. Then you actually have to have worker nodes to run the container. So you have control plane and workers. Pretty straightforward. And then on top of that, then you start doing cluster add-ons that are apps like Dashboard that run inside of Kubernetes. And then you have your user applications on top. So if you're trying to make this a network OSI model, it's not. But the idea here is that you get your prereqs installed, then there's two things in Kubernetes that you need, and then there's layers on top. And then this was the basis for actually taking the Kubernetes pieces, go full screen.
Yeah.
People found this drawing really helpful.
Yeah.
So if you look at that OSI layer, you can say, all right, before I start anything, I need a server with a network and storage. And then before I install Kubernetes, I need an etcd cluster, because it uses etcd is a distributed object store. I need a certificate authority, because it's all secure. So I have to have those two things in place. And then on my client, I have what people call kube control or kube cuddle. If you hear kube cuddle, it's not because there's a lot of hugs. It's the yeah. And so a lot of CTL things are being called cuddle. So it's and then so the Kubernetes itself is super simple. Once you have the etcd cluster, there's an API server that brokers all the requests. It is the center of the Kubernetes universe, and you can install as many of them as you want, and then load balance them, and they will basically go to etcd, that's where the data is, and they'll front end etcd for you, and then track where resources are. And then, to make everything work, there are two services. One's a scheduler and one's a controller that actually determine when a request gets made, where it gets placed, and they track resources and things like that inside the Kubernetes environment. So they sort of, the API server doesn't really do anything. These systems take the requests as they come through etcd, and they make decisions about placement and scheduling and keeping things up. And so all the magic is really handled by these two services. They're master-slave services. So you set up as many as you need, and then they will detect using etcd, or they'll elect leaders, and then they'll manage it. But they'll do that through the API server. So that's the three core services: API controller and scheduler. For once those are running, you have a cluster. Okay, and just from a example perspective, oh cool. Cell modems are slow. All right. So the reason why I show this is now that I've gotten that far enough down, when you look at what we're doing with this, you can actually see this is where all this, right, here's all the services, right? Certificate service, API server, kube control, scheduler, pieces like that. So, right, it's really just a bunch of individual pieces all working together. Yep.
Quick question, when on the cloud, when GC says we'll manage the master for you, could you tell us what elements of, is that the API scheduler, controller, is
Right.
the core master, or does it include proxy and kube? That runs at the nodes, right?
So the next level up are the node levels,
Right.
right? And so kubelet is the center of the universe at the node level. So it schedules containers. It basically manages the containers. Proxy does all the networking magic, okay? And there's a lot of networking magic, which is why people want Kubernetes. So, right, getting traffic, right? If you're using containers, the containers, you have to be able to talk from the one container to another container, or from the outside world to your container. And since Kubernetes is controlling where those containers are built and how they're IP'd, somebody has to be able to say, okay, I have a request and I know where to route the traffic. That's actually where we're the next, I'll show you our first passes at doing that. And then things get really sort of interesting because you can plug in different network layers or storage consumers under all this stuff. So there's layers and layers in this. We're trying to document these pieces. Yeah?
One more quick one, just if, say you want to use Amazon Cloud for this, what part is this, would be Amazon or somebody take this and what?
So Amazon's going to get you ready.
That's it?
That's it.
All right.
Right, and then you're going to need an etcd cluster. You're going to have to deal with all this stuff above Amazon.
Oh, okay.
So in that case, you're really just using Amazon as the infrastructure provisioner, like the.
That's exactly right.
Infrastructure as a service, whereas with Google Container Services, you're getting much higher in the Kubernetes stack. They manage the master for you.
Right, and Amazon has a competing service that does
Container
container
management.
management for you,
But it
Elastic
doesn't use
Container Service.
Kubernetes though, right? That's the thing.
Right. But it's going to integrate into all their services. And so even Kubernetes, there's load balancer integration. So if you do Kubernetes in Amazon or Google, it's going to, you have to configure it, but it's going to map into the load balancer. So if you spin up an application, the load balancer knows where to send the traffic to your application. Right?
Now I totally get what you said earlier about Google wanting to make it as simple as possible. Because if you're on Amazon, that's a lot of work.
Right.
Yeah.
We've been making progress on this.
There's a lot of tools that will automate it. You don't actually have to manually do
You shouldn't, yeah. If
CoreOS.
you can follow Kelsey's thing to do it the hard way the first time if you want, or part of what our goal has been is to make it so transparent that you're like, oh, I don't need to go back and do it manually because I can see all your steps. When we deal with operators love to, they don't like magic, they like gears. But, and then so on top of this, then you start getting services like DNS, things that manage heap, watch containers, and then all the way on top you have something called pods. So if you're dealing with Kubernetes, the language is pods. Pods are basically container groupings. And so you'll have multiple containers in a pod. There's something in here that I want to go back and add, which is a service. We probably won't get all the way there. What I'd love to do is I can come back and as we progress with this and keep showing you some of the operational stuff. All right, so there's 3 basic ways to install Kubernetes. And this is a map so that you can say, all right, I'm installing, so I have 2 masters It'd be 3 masters, but we're trying to keep things super simple. So I have a PKI domain, I have a network where things can talk to each other, Kubernetes, everything has to talk to everything else. That's the golden rule for Kubernetes, everything has to talk to everything. And so there's a master node 1, there's a second node that would be your cluster, so that some of these are active passive, some are active active, and then you have worker nodes. So it's 3 basic types of nodes, really almost 2. In this model, what you have is a host network, you have an etcd cluster running somewhere, you have your API server, you have your scheduler and your controller. That makes your control plane. Pretty straightforward. In this case, in the binary services case, those are just Go programs. And you just run the Go programs, systemd or initd or something like that. But you just run the Go programs on the systems. Poof, you have a Kubernetes cluster. And then on the controller side, you just need kubelet and proxy. Kubelet talks to the API server, and proxy talks to the API server and basically figures out where it gets instructions from that server about spinning things up. Pretty straightforward, really.
I'm sorry, this is really naive. I'm a developer. So these nodes would be like a virtual machine or like a physical machine, and I'd be installing these services with like apt-get or compiling it myself or however it is. But that's kind of the level that I'm operating at.
So the Go services you would download, you would actually do a wget
Okay.
the services. Yeah, so they're just Go programs.
Okay, so it's, okay.
So so the beauty of Go,
Yeah.
if y'all aren't used to Go, Go creates a single binary, and that's it. Works and it's Linux. So any Linux distro, that Go program will work on Linux, or there's compiles for Mac, there's compiles for Windows, but basically you pick your core, your kernel, and and that's it. You download the binary and you're done. So for Go, you just wget the binary, you check your SHA if you're religious, and then you go ahead and just run it with systemd or something like that. That's in this model. There's a variation. The next variation is going to take this another level of abstraction. But yeah, I mean, this is the thing. It's not really that hard. It's just 5 or 6 Go programs.
What about etcd and?
etcd is another Go program. So you configure. You need to build an etcd cluster, but it's it's very similar. Now, the devil's in the details, right? So networking can catch you, storage locations can catch you, SDNs and things like that. The goal here is for people who want to understand how Kubernetes works to read these diagrams and say, okay, I pretty much understand what's where in the infrastructure before we make people's heads explode. This map is the next variation. It's called a static manifest. Static manifest is when you install kubelet on your nodes. So kubelet is a container runner. And so what you do is you put Docker, right now I'll assume Docker, put Docker on, you have a network, you take kubelet and you give kubelet a manifest file for just that node. So normally you take a manifest file, Kubernetes sprays it across the infrastructure and you're good. In this model, you write a single manifest, what they call a static manifest file. So it only runs on this node. That then turns around and pulls down Docker containers that contain the Go programs and run them for you using Docker as your daemon manager.
That's the self.
This is not self-hosted yet. This is what next step.
It's a hybrid.
Next step. So the idea here is that if Go programs, and this I'm biased because to me Go programs and systemd are really simple, but some people are like, I love Docker so much, I'm going to wrap my Go programs in Docker and then run them in Docker instead. So this is the way a lot of the deployment tools do this, and then what they'll do is they'll do a Docker pull. They'll pull down those Docker binaries, and then they'll put these things in. And then the same thing happens. So instead of running the Go programs, you're running the Go programs wrapped in Docker containers. Make sense? Not a big step. Self-hosted is where it gets a little confusing. It looks incredibly similar, right?
This is an interesting one though.
So the only difference that you'll notice here is that there's an extra static kubelet down here. What self-hosted means, and actually because the self-hosted guys themselves will say, hey look, we're going to run, we're not going to make a generic cluster. That they'll say is even self-hosted you have master nodes and worker nodes. What self-hosted does is it says, oh, once I've gotten the control plane going, I could actually tell the control plane to manage kubelet on the control plane. And so what happens is this static kubelet, the new version, will allow you to say, oh, you were running this container in a static way, but now I want you to switch to running it in a dynamic way. And it turns off its own, it turns over static control to Kubernetes to run dynamically. So the control nodes actually start managing the containers of the components themselves. And so what happens is then you get to use Kubernetes networking and stuff like that. Pausing. I'm an operator, or I deal with a lot of operators, and when something breaks, they want to go point to the thing that broke and fix it. And so I'm less excited about the strategy. But it's a cool idea, because then what you can do is you can say, oh, I need to patch Kubernetes. You tell the Kubernetes cluster to patch itself, and then it goes through and brings in new containers and rolls the upgrade and does all that type of stuff.
It leverages itself to manage the extra components, basically the non-core.
The idea is that Kubernetes is really good at taking containers and then managing changes to those containers in a controlled way. So if you've packaged Kubernetes in containers, you might as well use Kubernetes to manage the containers to do it.
Right.
This is self-hosted. I'm still working on the right way to explain it. So, but this is the other thing. This is considered incredibly hot. People are very excited about this strategy. Well, that's a whole other topic about that. But
We got more meetups coming down.
yeah, we do, and it's an interesting topic. Yeah.
I had a question not about self-hosting or otherwise, but and if you are going to get to this later, just tell me.
No,
But
go ahead.
I noticed that in all of those maps you had independent masters from nodes. Is that because I know some of the documentation? Like I just went through the Kubernetes from scratch documentation, and they're sort of like, you don't actually have to do that. And actually, the cluster I stood up for various reasons, and it's gone now. It got deleted. It's the test thing. But I didn't do it that way. I just let the master be another node and accept jobs. Right? Is there you're talking about doing describing the canonical installation? Is that an option in the canonical installation? Are you agnostic to it, or are you?
So you can totally do it. They're just services running on the nodes.
Yeah.
For the cluster ops documentation, we decided to not do that, because what we're sort of doing is writing the base pass every operator sniff test instructions. Okay. And so while it makes perfect sense for a developer for a small cluster, it's if I'm a bank who wants to see how to install Kubernetes, it's going to make their heads explode. So we sort of opted to the sure, you're buying more hardware than you need, but you got 1,000 nodes. You're trying to build a 1,000 node Kubernetes cluster. You're going to put 3 controller nodes in it, and they're going to be busy anyway. So we spent a lot of time arguing about that stuff, and we were like, no.
Was the question whether to run compute on the master node itself?
So you can put the controller anywhere you want.
Right.
All right, and with self-hosted, you would argue the controllers could be anywhere in the cluster.
Yeah.
I'll tell you, as an operator, if you told me I don't actually know which server is running my API from, I would.
I didn't do it that way.
Thank you for the conversation. It's been really nice to see you. So, right, that's, and this is the difference between operators and developers, right? Operators are thinking, I'm building this today, I'm supporting it tomorrow. Developers have a tendency to be like, I tore that down last week. That's old, that old version, who cares? And it's a perfectly reasonable disparity. It's just, that's the thing. This is the beginnings of the network mapping And you can see, you can imagine what the hour-long conversation that generated this picture created. It's useful if you look, yeah, this is a 6-month project. This is day 1 of a 6-month project, basically. The idea here is that every node has some public IP address on it, some addressable IP that gets routed and NATed and ARPed, if you know the networking. And then there's some private namespace behind the scenes that you have to magically figure out how your containers talk to each other and the internet through various options. And there's at least 3 different ways that this magic happens for Kubernetes.
Is the canonical way recommended the flannel or whatever, the overlay?
Flannel is the leading one. And we actually deploy Flannel by default. We really like it.
Okay.
But it's not, there's a ton, it's a whole other Meetup topic.
There's some commercial options probably, right?
There's a couple of different ways to do it, including none at all. But right now, if you're just playing, use Flannel. As you get into something that really needs production or hybrid or some more performance, Flannel probably will not scale that well for you. That's been the thing. All right. Yay. And this actually finished. And I've gone way longer than I intended, so I want to leave you some time. Great questions. Any wrap-up questions or?
Those slides, can you share them?
These are all, everything I showed you is actually out of the Kubernetes. I'll hashtag a link to the doc using the K's ATX thing, and then all of these are actually working docs from cluster ops. So they're not slides per se. But, and then if you just Google rebar.digital, that's and you can see videos to this stuff where our CTO goes through like a 20-minute, takes this thing, it takes 20 minutes to pull it apart, which is sort of fun.
Rob, do you want to maybe give out your Twitter handle so people can?
Oh, thank you. I'm Zehicle online. Z-E-H-I-C, like vehicle, but with a Z. Been using that handle for about 10 years or so. I'm usually Zehicle on just about everything. So nobody can spell Hirschfeld reliably. So I'm Zehicle.
Awesome. Well, thanks. If anybody needs to use the restroom real quick, it's right around the corner. Take like a quick bathroom break.
Give you time to get set up.
There.
I have a quick question if you
Sure.
don't mind.
I'll take questions by you.
Yeah, go for it.
On the complexity scale, because obviously I understand now what Kubernetes is hard to manage on your own. I mean, I can see it. A lot of times when you're experimenting, you're using Minikube or you're just throwing it up on the cloud and you fail to realize how much there is to it.
Right.
But in the context of on-prem, how would you compare this to like setting up Zookeeper or Kafka or, I mean, how
That's a great
like,
question.
relatively speaking, how would you?
Kafka or something
Any
like.
any other distributed example?
So we actually think Kubernetes is pretty easy.
Okay.
Compared to like a Hadoop cluster.
Yeah, that kind of stuff, yeah.
It's actually a pretty easy infrastructure.
Okay.
It's etcd plus the API server. It's really not that hard. The certificates will throw you if you're not used to building certs.
So,
And that to us
nothing
is
to
one of the
contribute
big,
to the Twitter handle.
one of the best challenges.
How about the packaging aspect of like CoreOS and others are providing things that you can't, like,
So
you know, vendor, like, this seems like you want to compile it on or you want to use apt-get or, right? Eventually, Kubernetes will be formalized.
eventually it will, or it'll be packaged in containers, and you'll just download the new containers. You know, it's Go programs, so from a packaging perspective, it's super simple, which is why my team loves Go. Yeah, so it's, you know, compared to like, so we did a lot of OpenStack work.
Yeah.
It's awesome. I mean, OpenStack has got about 15 services. They're all Python, so they have weird dependencies. They have configurations all messed up. It's night and day difference. Much.
Thank you.
Before Thomas gets started, I got a sign-in sheet. You just really want to put your name on it. You don't have to put your company, email, phone number. You can if you want. I'm not going to reach out to you and try to sell you something. But I want to keep track of who all's come to these things. So I can shame the other 30 people who didn't show up.
I have a question.
Is Rebar a product or like a services?
It's a product. It's an open source project, so it's a standalone thing.
Oh, cool. Alright.
Yeah, we do not currently offer it as like a hosted service. Maybe in the future.
Should we get started?
Yeah.
Okay, sweet. Hi, I'm Thomas. I work at uStudio, again, as the shirt says. And I'm going to talk about how we run Kubernetes at uStudio in production. First, who are we? I think this is the latest tagline. I don't know, probably it isn't. But we make video easy. Essentially what we do is you give us video, and we can do whatever you need to with it. We can just send it to YouTube or Vimeo if that's what you want. We can host it in an interactive player if that's what you want. We can enable you to build like crazy interactive HTML and JavaScript based like almost applications on top of your video player. They're really, some of them are pretty amazing. And we can integrate with all sorts of things. We have Salesforce integrations and WordPress integrations and marketing automation tool integrations and LMS integrations. I was going to say our tagline should really be, if you have a TLA, we can integrate with it, because we integrate with a lot of stuff. We're API first. It's how we do that. So everything is built on top of an API, and then we have any UIs that we build are just talking to the API. So anything you can do in a UI that we show you, you can do automatically with an API. I am Thomas. This is my GitHub page. I'm not on Twitter. I'm sorry. I'm not. I'm a full stack developer at uStudio. We have a relatively small development team at uStudio, and so we basically all have to do everything. That means writing UIs, writing CSS, writing back-end services, and getting them deployed and running on servers, and being on call and fixing things when they break. Everything. And most of us really enjoy that. I think it's a lot of fun. It's not always fun when your pager goes off, or PagerDuty goes off, but in general it's really a lot of fun, and I really enjoy that, and I love getting to see just the whole stack. And that's really kind of what drove us to Kubernetes, so I'm going to get into that real quick. So this is kind of where we were, and we still have stuff here, so I'll get to like our current state. But we had a sort of semi-service oriented architecture. We're always kind of hard on ourselves about like exactly how we built our application, and oh, I wish I'd done this other thing better. But I think overall, we actually had a pretty nicely, or we still have, a reasonably nicely contained and encapsulated system. Mostly we run inside Rackspace. We're not stuck in Rackspace. We're not limited to Rackspace. We do things and use other service providers, and we can integrate with other service providers. But that's kind of where a lot of the core stuff is. We kind of have a pretty traditional cloud application infrastructure where we have an application, we create N nodes to host that application, hopefully more than one. If it's an HTTP-based application, you stick it behind a load balancer, and then all those nodes do is run, however many instances of, in our case, we generally do Python on the back end, so however many instances of Python we need to do to manage the load we need. We do our deployments from master, so the way our dev, build, deploy cycle works is you make a branch, you do your code, you open up a pull request, it gets approved, you merge to master, now you're blocking. So we have Fabric. If anybody's a Python developer, they might know Fabric, but it's kind of like a combination between both make and an SSH automation tool, so it does both things. But basically we can use Fabric to provision new servers or run a deploy on existing servers. And all a deploy means is run Puppet. And then, or really what it means is pull down any changes to Puppet since you were last deployed, and then run the Puppet manifest. And then Puppet takes care of, okay, pull down the latest version of this, pull down the latest version of that, restart this process if something changed, etc. Internally, we use libcloud and a little bit of Pyrax inside of our Fabric tool to do some of the server provisioning stuff. We don't use like Puppet to create servers. I don't know if anybody's done that. I know like Ansible and Salt do that, but we kind of have a pretty strict distinction. Locally, we used Vagrant, and then we had a pretty good. I think it was pretty good. You can run one command, and it's this fab environment stage or prod project. This is the project I want to deploy. Verify deploy, and it says this is what I'm going to do, and you say yes, and then it does it, and then it's done, which is pretty cool, and it lets us do continuous deployment and things like that. Puppet is, first of all, it's a little slow to run. We're not running in a Puppet master environment. Puppet is also very hard to maintain. It does not work the way it is supposed to work. Or the way a developer would expect it to work is maybe the fair way to say that. Like I said, when you merge to master, you kind of block production. So you merge to master, and now if anybody needs to like create a new server in production, they're going to get you the code you merged, and you haven't tested it yet, potentially. So that's always been kind of a problem. We're kind of running into some, I would say, limits of rack space in terms of what they can do, how fast they can provision new servers, things like that. And also a lot of other cloud providers are going after a lot of things, like Google and Amazon and Microsoft are all like, we'll provide databases for you, and we'll provide queues for you, and we'll provide all these other things for you. And Rackspace is still really focused on the infrastructure for the most part. I don't think that's entirely true. But they have a lot of catching up to do, and obviously, like you were saying, OpenStack is an interesting beast. Also, single service nodes can be kind of expensive. You want to stand up, 2 or 3 nodes so that if something goes wrong, your service is still running, but maybe it's a kind of a low volume service and you're spending money on at least a couple nodes when they're not really doing much at night or something like that. It was also it took a long time to, I say creating, writing the ops code to deploy a new service took a long time. You ended up copy pasting a bunch of Puppet code that you hopefully understood at least the general concept of, and then creating servers and all of those things. So this is what we wanted. We wanted to start breaking some of our more monolithic applications out into separate services. We also wanted to start developing new features as independent services, and in order to do that, it needs to be easy to create a new service. We also didn't want to be too tightly coupled to our cloud provider. We want the flexibility to switch, but more important to us is the flexibility to be in more than one. The other thing we kind of learned, software as a service databases are totally cool. Depending on, obviously a lot of this depends on your data and your workload, but for a lot of sort of day-to-day stuff, they can actually be cheaper than running like 3 Mongo instances in a replica set and making sure you're backing the data up and then deleting the old backups so you stop paying for them and all of those things. So we wanted something that fixed also all the problems I stated on the previous page. And so we picked Kubernetes. What Kubernetes gives us is, I think this is the kind of the core thing, is that it's a higher level deployment primitive. So as a developer doesn't need to think about, I need to install Python, and I need to install, I need to apt-get install Python, and I need to apt-get install virtual env, and then I need to create a virtual env, and all of those things. A developer just wants to say, here's my application, please run it for me. And we're all only developers. We don't have ops guys. So there's not a team of people to go build something for us that makes us pretend like that's how the world works. We want it to be as vendor agnostic as was reasonable. Our application itself is very vendor agnostic, but our infrastructure automation tools are not as vendor agnostic. And then the other thing is we wanted something that we felt confident wasn't going to get forgotten about in 6 months, and so that we could really we don't want to do this again next year. So we picked Kubernetes, and to your question, this isn't literally how we created our cluster, but this definitely works. You do that, and then it like runs a bunch of bash scripts that create a bunch of AWS resources. It actually creates like auto-scaling groups, and so you can go in and like click a button in the console and like, I don't want 2 nodes, I want 50 nodes, and then wait, and then you will have 50 nodes, and they will all be registered with the master. What this doesn't give you is stuff like redundant masters and things like that. So this won't give you like a real production cluster, but this actually gets you pretty close.
Is that CloudFormation behind that?
This does not actually, at least in version 1.2, the last time I looked at it, it's not actually using CloudFormation, it's just using
Its own scripting.
yeah, it's just using the AWS CLI to like create all the resources it needs.
And it's actually provided by Kubernetes then?
They host it. I'm not sure who wrote it, but they do host it. There's some other things in addition to things like making sure that you're using the instances you want and your networking is configured the way you want it. There's some other things that you really need for production deployment. You need to monitor your servers. You want to get told when they're using all their CPU or they have no RAM or they don't exist anymore. You want to know what logs your application is printing out, and you want to be able to search them and get alerts if they're logging terrible things are happening. You want to get alerted when your application knows that something's wrong because you're getting a bunch of exceptions or things like that, and you want something to monitor uptime. That's actually has nothing to do with Kubernetes, but you need to do it. So these are the services we use for that. We use Datadog for just server monitoring, CPU monitoring, things like that. They have a bunch of other stuff. They can actually monitor Docker containers, and they can monitor all sorts of stuff. We actually have like things where we like hook up our queuing system to Datadog, and we can get a graph of like how many jobs are in the queue over time, and alert when there's more pending jobs. There's too many more pending jobs than running jobs and things like that. We use Sumo Logic for logging in Kubernetes. And in our normal deployment, we actually install the Sumo Logic collector on every box and tell it like where all the log files are, and then it reads them in and ships them off. The Sumo Logic collector is written in Scala, and some of our nodes we like to have like lots of little nodes that we can scale up and down quickly, and Java and little nodes don't like each other. So, so that's kind of a problem. So what we ended up going with here is we use FluentD, which is if you just stand up the like Elk stack, Elasticsearch, I guess it's not Elk, it's Elasticsearch, FluentD, and Kibana, like logging add-on inside Kubernetes. We took the FluentD part of that and we modified it, and we got rid of Elasticsearch and Kibana. Somebody has already written a FluentD plugin. So basically the way FluentD works is you have sort of inputs, and then you have all these filters, and then you have outputs. So the like built-in Kubernetes add-on has an input which says, go find all the logs for all the Docker containers. And then it has a filter that says, it has other filters, but the primary filter is like a Kubernetes filter, and it actually extracts metadata based on container names and things like that. I can actually say like, hey, this log line came from this container inside this pod with these Kubernetes labels on them. And it sort of aggregates all of that. Yeah.
So you said it's use FluentD, Logstash, and Sumo Logic are Kibana equivalent like the...
We don't use Logstash. So
so what did you say?
the standard Kubernetes add-on is not actually Elk. I said Elk, but I was wrong. It's Elasticsearch, FluentD instead of Logstash, and Kibana for searching. We only use the FluentD part of that. Sumo Logic is a SaaS service for log aggregation and searching and filtering and all sorts of stuff. And so Sumo Logic is the Elasticsearch / Kibana half. And there's a FluentD plugin which just takes every log line and sends it to
FluentD instead of Logstash, or Fluent instead of Prometheus, or any of those?
We picked it because it's sort of the standard.
Okay.
And there were already Kubernetes integrations for it. And it's written in Ruby, not Java, so it doesn't take up 5 gigs of RAM. We also, application alerting is sort of an ad hoc thing for us right now, where applications register, uncaught exception handlers, and then send emails via our email provider to the dev team. And we kind of wanted to fix that when we were doing this, so we came up with this mechanism, and we have 2 libraries Python libraries out on PyPy and GitHub. I didn't write their names down, but they essentially, one of them, all it does is you give it a pod info volume mount from Kubernetes, and it slurps up whatever data you've asked Kubernetes to put in there and gives you back just a nested dictionary of metadata about the pod that's running. And then we wrote another thing for Datadog that just registers a log handler for the Python logging library, which is a Python version of log4j or log4.net or whatever. And then it just says, anytime I get an error or higher exception, I'm going to take the error message. I'm going to take a bunch of metadata that you've given me, which we extracted from the pod, so the label, the namespace, whatever metadata you want, and I'm going to send it as an event to Datadog. So in addition to metrics, Datadog has events, and they're just like, this thing happened. And so we send an event which says, this error happened, and then we can set up inside Datadog filters and monitors that say, hey, if there's this many events in this much time, email the developers, or tell PagerDuty to wake up the developers, or whatever it is. For uptime monitoring, we just use Pingdom. Like I said, it has very little to do with Kubernetes, but it's an important thing to have for a production service. One of the things that attracted us, I was going to put this on the earlier slide and I forgot to, one of the things that attracted us to Kubernetes is that it uses configuration over convention, which is really nice when you don't want to do things the way somebody else wants you to do them, because you configure how you want to do them. And that's great when we go out and we find some third thing. Oh, I forgot to say, Datadog has a Kubernetes integration. If you use Datadog and you go to their integrations page and you click on Kubernetes, they give you a YAML file. It creates a daemon set, and it just runs Datadog on all your nodes. And it slurps up. It knows that it's Docker's installed, so it like slurps up all your Docker container information, and you get graphs of there are these many Docker containers and they were labeled this way and all that stuff. So if you use Datadog and you...
I'm just curious, did you look into Prometheus? I know it's like, you know, Borgmon was Kubernetes internal, Google's internal, and then the guy came out. There's a lot of chat on Prometheus, so I'm just curious if you looked into
No, we mostly just, these are the service providers we already had, and we didn't want our Kubernetes, I guess I should say that, we didn't want our Kubernetes data to go somewhere different from the rest of our data. So all of our other nodes are tracked in Datadog. These nodes should be tracked in Datadog, and the same thing for Sumo Logic. However, when we build our actual applications, configuration is very verbose. And so among the developers that we have, we would like to all build our applications the same way. We switch around a lot. We don't have like, Fred's another developer here at uStudio, so I'm going to pick on him. Fred's not like I only work on this and nobody else works on this and I'm the guy, right? Fred goes to Jira and says, what's the next project? And he grabs one, and I go to Jira and I say, what's the next project? And maybe he takes the thing that I was working on and I take the thing that he was working on. So things need to kind of work the same. So for our internal tooling, we like having convention over configuration because A, it keeps everything similar, and B, there's less typing. And developers hate typing, even though they have jobs that require them to do it all day long. The other thing is, so this is kind of like how we did it, how we used Kubernetes. So application configuration, we decided to just use Kubernetes secrets and environment variables. Environment variables are nice, they're easy. That's how Heroku does things. That's how we've been doing things. That's like the 12-factor app, right, thing. So that's pretty simple. We used deployments. We started in 1.2, so deployments were kind of like a new thing when we started. But they're not a new thing now, and they're awesome, and you should use them. And services, and we just create load balancer type services. And so because Kubernetes knows it's running in AWS, anytime you create a new service, it just goes to AWS and says, I would like a load balancer, please, and add all the nodes to the load balancer, and then I will manage the traffic and make sure it gets to the right place, which is pretty sweet. And then the one thing it doesn't do is it's a layer 3 load balancer. So all it knows is that I'm doing TCP or I'm doing UDP, and that's it. And this is the port. So it can't do TLS. So what we do right now is we have an Nginx sidecar container, which is, I don't know, is that an official term, a sidecar container? It seems like it is. Basically, a pod.
That is another meetup topic right there.
A pod, logically, most people think of them as a single container, but they can actually have more than one container. In this case, we take big advantage of that, and every single instance of our app has an instance of Nginx running next to it, doing TLS and termination, and then the app is only listening on localhost, and Nginx is talking to the app. This is probably not super efficient in terms of compute resources because you have way more versions of Nginx than you absolutely need. This is actually, on the other hand, you want to be doing TLS between your load balancer and your application. You do not want unencrypted traffic really anywhere. Inside localhost, it's inside shared memory. It's going to be hard to avoid that, but it does sort of solve that problem for you. This is another pattern we did. So every application we have in its GitHub repository has a deployment folder, and inside that has a bunch of YAML files. And then when our automation scripts want to create an instance of this application, it just creates everything in all the YAML files. And it does some other things with secrets and things like that. So I'm going to dive now into, so secrets. We looked at things like Vault and stuff like that, and we might eventually use them, but for now we just want to use secrets. So what we actually do is we use our password manager, which the nice thing about your password manager is it is encrypted and it's backed up and you can control access to things, which is nice. And so we just have an automation script that goes to our password manager and says, hey, what are the secrets? We have sort of a convention of how you store secret values in the password manager, and it goes and it says, hey, what are the secrets for this application in this environment? I'm going to pull them down and I'm going to stick them as secrets inside Kubernetes. And then inside the app, we expose those secrets as environment variables to the application, and the application just says, OS operating system, what's this environment variable? That's how I connect to Mongo. Yes?
So when you go, we're actually in the middle of this problem right now, but when you go to change one of those environment variables or one of your secrets,
one of the values or one of the names, or add a new one?
let's say one of the values then,
Okay.
like a AWS key changes
Sure.
or something crazy. How do you refresh? How are you currently refreshing the pods so that you get the?
That's a manual process for us right now. We just go grab the list of all of the, since we're running inside a deployment, you just get the list of all the pods that have the old thing, and for each one you just delete it, and then you can, I know there's some talk about adding, porting the rolling update from, I always get confused about replication sets and replication controllers, from the old one to work with deployments and say hey, force redeploy this thing.
Right.
For now that's manual.
Yeah.
We don't have to do it that often.
Sure.
Actually, the other thing that we found was really annoying. So because most of the time we were doing this for new applications that didn't have a fixed configuration, our initial sort of way we passed secret values down as environment variables was in the YAML. So you have a dictionary and you say, here's my environment variables, and you say, my AWS key, and the value should be from this secret and this key and the secret, and my database password, and blah, blah, blah. What we found was it got really annoying to change that dictionary inside the YAML file every time we needed to add a new configuration endpoint. So we'd be building a new service, and we'd be okay, we're going to spend, first we're just going to get the service talking to the database with the health check route, has actually no functionality in it. Okay, now we're good. Now we need to go build this feature. Well, this feature needs this one configuration value. I need to edit the YAML file. I need to kind of push this new YAML file out to Kubernetes. It kind of sucks. So we stopped doing that. Instead, we have a single secret, which is a shell script called environment.sh, and we mount that secret as we mount the secret as a volume into /app/secrets. And then the Docker file entry point is source secret/environment.sh exec my application. And what that means is that if I change this shell script and I push a new value of the secret, all I have to do is restart the app, and the script will set all the extra environment variables, because this literally is just export AWS key equals thing, export blah equals blah. It kind of sucks that Docker you have to run a shell command instead of running the app directly, but it kind of works around that problem. So it kind of solves part of the problem of
If your secrets are now in that volume, on disk of that volume.
Yeah,
Which,
they're
I don't know if it
sort
passes
of
or not.
on disk. They're not really on
No.
it. Yeah, yeah.
If your container or something got hacked, they could go to the environment.ch and sh. I don't know, it's an operator's maybe security, I don't know.
Is that any different from printing env though?
Yeah, I mean Docker
Just
like
saying
knows the
idea is
environment.
just
of the
anything
container.
on, normally the concept is on disk, you know.
Right.
Yeah.
Like I said,
But you're right,
Yeah.
you know, today, most people that deploy, they'll have a separate local, like a local where they
Yeah.
keep in a protected file system of sorts.
Yeah,
with
I mean,
access.
the old way of doing this was using Puppet to drop these values
Right,
somewhere,
right,
right?
so-
So, at least now it's inside a Docker container.
Yeah,
And it's managed by Kubernetes. Like I said, we will probably eventually, as we grow, we anticipate wanting to grow into something like Vault or something like that. Or not wanting to grow into something like Vault, but eventually needing a sort of higher level secret thing. So this is how you create a service. I actually set up a demo if there's time and people are interested. Let's see here. So here, this is a root repository, and I have a bunch of symlink. I've got a bunch of, go ahead, yeah.
My eyes are pretty weak.
I can make it even bigger
Magnify that up.
if I remember the keyboard shortcut.
Is it Command Plus? or
Yeah, it is. It's just, I think it like, there it goes. It's just doing this odd thing. Yeah.
Thank you.
Yeah, is that good enough?
Yeah.
Okay, sweet. So this is a repository we have. It has a bunch of automation scripts in it, and we create symlinks from here to all of our applications. So I created a sort of silly one that does almost nothing called kube env test. So this is sort of like when you do a git checkout, that's what would be inside kube env test. It has a Docker file, it has an application, and then it's Python, so I have a virtual env in here. But the key thing here is the deployment folder. So we have YAML files. You can ignore my editor's temp files, but in this case, just to demonstrate, I have the actual application, app.yaml has the deployment in it. So this is an interesting, it's like typing on a roller coaster. This has the deployment in it. It says these are the containers. In this particular case, because I was actually throwing something together, I'm overriding the command from the Docker file. We don't actually do it that way inside production. And then inside service.py, we define the service. It's a load balanced service. So what we do if we want to start the service,
and that's the convention you have. Every repo will have the deployment
Yeah.
folder and the YAMLs.
yeah,
right?
and we actually, it can actually get a little more complicated than that. Like, say inside our local development environment, we want Mongo. Well, in real life, Mongo is being run by some SaaS provider, but locally we don't want to have to go talk to it. So you can have like subfolders of deployment with YAML files that are specific to an environment. So the way you start a service is you run start service, and then you say which environment you want to use, which is dev, and then you say which service you want, you point it at the folder, and then it goes to the password manager and it downloads a bunch of stuff, and then it creates all the things. And now you can see the app is running. Let's see here.
So you're actually running, where is it actually, your plug?
This is just Docker machine right now.
So you have Minikube or something? Where's it actually?
I'm using Docker machine,
Oh.
and so we still use 1.2 because that's what we used when we created a cluster, and we haven't bothered to upgrade yet. So we do what was the standard way of doing it when 1.2 was a new thing, which is you just there's a Hypercube Docker container, and you just run the Hypercube Docker container inside your Docker machine, and then everything just gets created for you automatically. Yeah. Now that's not the way to do it. That's fine. Don't do it the way we do it. But it works, and it's already managed by our automation scripts. So that's we will eventually upgrade for sure. But so here you can see the pods. You can see the service. And so here's our port, and then I can go grab my port number, and I can curl, and then change my port number. And then I've got version 1 parameter, and then this is, so here you can see real quick, that is tiny. Here's the application. I'll make it bigger in just a second. Okay, so this is just a little Python Flask app, but essentially it's reading an environment variable out of the environment. So this would normally be a secret, some sort of secret value or configuration parameter. In this case, it's the string from Kubernetes. And then we have a version number. You'll see here, this says version 1 because this is an old Docker image, and I'll get to how we deploy new Docker images in a second. But so here, we've got our app running automatically by running one command. So the next thing we do, I hate that part of Mac OS. Anytime. Okay, so that's how we create a service. You start the service the exact same way in stage and prod as you do in dev. The only difference is in dev you do it often. In stage and prod, hopefully once, never again, per service. Deploying services. So the initial way we did it was we ran kubectl edit deployment, and then it opens up the YAML for your editor, and you go find the image, and you change the image tag, and then you save the file, and then Kubernetes does it for you. That's not very automated. So, well, what we've always done is we've done build in our CI. We use Circle CI, but it works anywhere. So in our CI tool, you merge to master. When a build happens inside master only, we don't do it on our branches just to save space and time. But you obviously could. And it's kind of a thing you can do per branch. But anyway, after all the tests pass, everything's cool. We build the Docker image, we push it to ECR. We also tag it as latest. I think I have a slide about that, so I'll move on there. So now it's in ECR. Kubernetes, like the stage version of Kubernetes is pegged to some version of our app. The prod version of Kubernetes is pegged to some version of our app. If we're pushing out a new version, hopefully it's because we added a new feature, so those versions between stage and prod are the same. And we're about to push out this awesome new feature. And so what we would do is kubectl edit deployment. We sort of like select the stage context in kubectl, and then edit the deployment, and then change the image name, and then it would automatically run the new service. And so then we tell QA, hey, new feature, test it out. They test it out. They tell us we're awesome. And then we do the same thing in prod. And you have to remember, okay, which version did I deploy, and did I switch context inside kubectl, and all of these things. And it gets a little hairy. So we wanted to automate that. So that's what we did. So here I have, and we sort of switched halfway through from Python to, from shell to Python, because we started doing things that are.
So you mentioned your service SOA, like, I don't know if it's microservices, regular services, but so you're not just deploying, you're deploying these things, multiple things separately, right?
Yeah.
Per service.
Yeah, we're just like, okay, I have finished the pull request for the service that does this thing with the video.
Right.
I'm going to push it out.
Got it.
We do continuous deployment, so we don't do this thing where like at the end of the sprint, whatever's ready gets merged, and then we go do some big build and some big deploy of the full stack. We just say, I added this feature to this app. Or sometimes it's I added half the feature to the app because half the feature belongs somewhere else, but I'm going to deploy that and make sure I didn't break anything at least, and test what I can, and then kind of do. So we deploy many times a week, which for a team of like 6 devs is a lot of deploying. But we actually really like it. And this makes it a lot faster. So here we've got deploy.py. So I want to deploy that thing, my environment. I'm going to use the short things, but these all have long names too. My environment is dev, my project is kube-env, and I want to deploy a build which is called local-2, and I want to watch the deployment happen. So this does a deploy. It says, hey, this is what you're going to do. You're deploying to dev. This is the container we're changing it. We're changing it to 2. Is that what you really want? I say yes. It says sweet. And it goes and it uses kube control patch to just patch the container and change it. And then you can see this is all Kubernetes. This is all deployments, the API server and the scheduler, and they're all doing all this stuff. And so now, when I curl, I have version 2, and I'm done. That's that. Locally, like I said, we use Docker machine. One of the nice things about this is if you create your Docker machine, because we use Vagrant for all of our existing stuff, and they need to talk to each other because we're not like done moving everything over. So we use, inside Vagrant, you can say, give the machine this IP address in this sitter range, and then when you create a Docker machine, if you're using, for Vagrant we use VirtualBox. For Docker machine we also use VirtualBox. If you tell it to get an IP address in the same sitter, they will get the same private, like internal fake network on your box, and your computer and your Docker machine and your Vagrant or N-Vagrants will all have IP addresses, and they will all be routable to each other. And that makes testing the two relatively simple. So I'm going to talk a little bit about what we're going to do in the future, if nobody has any questions about how we're doing things now. Updating secrets right now, if we change a secret, what we have to do is delete the old secret and rerun the create secret script. That's kind of a minor thing, but it's annoying. Slack notifications, that fabric command I showed you earlier where you say fab environment stage, blah, blah, blah. It actually like sends a message to Slack and changes the topic to say like, Thomas deployed this at this time to this environment. So we want to just port that over. The other thing is writing all the YAML files is kind of verbose. That YAML file I showed is like 1/3 the size of like a normal one. Every time you create a new service, it kind of sucks to like, well, I gotta like copy this file over, I'm gonna change all the names and blah, blah, blah. So we would like a way to like, one of the tools we would like would ideally be to sort of drop in sort of like, here's like, oh, you want an API? Well, you're gonna need these things, here they are. Oh, you want something that's listening to a queue? Well, you're only gonna need these things, here they are. Some people want chat ops, some people want to be able to deploy from Slack. And then some people, some people want to be able to deploy from the web. I'd really rather see a dashboard of like, here's stage and here's prod and these are the versions and here's a drop down and this is the version and by the way, here's the merge commit from that. Like, I want something like that. My personal preference.
Just as a question, I mean, I know it's opinionated, but like a platform as a service, like Days, I mean, you're building your own plumbing to deploy, right?
Yeah.
That's what Days is trying to do.
Yeah, I got that
Yeah.
coming up. Was there another question? No, okay. But anyway, the command line is nice. Actually, I like the command line. So, and most of us I like the command line. So, but there are certainly new ways we could go. This is another thing. This is like a concept that feels a little weird inside Kubernetes. And Deis seems to be going after that, but I don't feel like they've solved this problem the right way. But I haven't like used it for real. So, so at build time, you have things like environment variable names. These are the configuration points at build time. These are the volume, like this is where I expect this volume to, like I expect my data volume to be here. These are my containers. These are the labels of the app, most of the labels of the application, et cetera. The environment, which is dev or stage or prod or whatever, these have the values. So your application says, I need a configuration value and it's going to be the AWS key. And then stage says, your AWS key for stage is this. Inside the Kubernetes YAML file, like secrets sort of enable that, right? Secrets let you say, fill these in later. But the fact that you have to kind of list out which ones you have gets a little funky. But anyway, the environment also says volumes. So in dev, you're probably not going to mount a block storage volume. But in stage and prod, you probably are going to mount a block storage volume. But regardless of where it came from, it all needs to end up inside the same place. So the app expects it in a particular place, but where it comes from is dependent on the environment. And then also another thing is like replicas. Like in dev, you really only want one instance running because you want to easily be able to see. Like if I curl something on my box and it broke, I don't want to go say, well, which 20 instances of the process got that request and go find the error. I only need one. But in stage and prod, you want more than one. And the image tag is kind of like the join of all of these things. This image expects this configuration points, and when you send it to stage, you need the right values for that configuration point. And that's something we kind of struggled with. The environment.sh solved some of the day-to-day kind of friction there, but I think there's still a little bit more, like it doesn't solve the volume, like it doesn't solve that for volumes, and it doesn't solve that for other things. So things like Deis. So Deis is interesting. It's interesting because, so we looked at it. I'm personally not a fan of push to deploy. I don't like the deploy not coming from GitHub. I don't like that I can like make a commit and then push it and then it never ended up on GitHub. That feels like bad juju. And you can, I'm sure you can configure Deis to like check and make sure the commit came from GitHub. But just in general, it's not exactly how we as an organization tend to work. But the YAML is really verbose when you really start like filling everything in. And within our organization, there's patterns and we want to reuse it. So it kind of sucks that like inside every API thing, we have to go take the block that describes the Nginx container that has the like config volume map and the SSL key secret volume map, and we have to like copy paste that over. That is like a subset of the pod. It's not the whole thing. So Deis is about like, oh, I need Mongo. These are the resources I need to run Mongo. Or I need Kafka. So these are the resources to need for Kafka. And by the way, Kafka needs Zookeeper. So go pull in the Zookeeper like and down the thing. But internally, we're more interested in, I want to define an application and it needs to do SSL termination, and just turn SSL termination on, and I don't really want to think about exactly how that works. You should know how it works, but it's probably always going to work the same way within an organization. Health checks are the same thing. You have like each health check is like 6 lines because you've got the liveness probe and the readiness probe, and for us they're the same, but you sort of have to copy paste them around. Things like that. It would be cool if there was a way to sort of define a YAML as a collection of sort of in-between concepts. So say I want the pod volume mounted here, and not like, to mount the pod info volume, you have to define a volume at the bottom, and then you have to go into the container and tell it where to mount it. And that's nice when different people want to mount it in different places, but inside our company, we always want everybody to mount it in the same place just because it makes things easier. And we don't want people to be like, well, where should I mount it today? Things like that are sort of interesting problems. One of the interesting things, though, is that Kubernetes actually, like, it takes you up pretty high in the stack for an application developer. So while the YAML is a little verbose and it's a little annoying to write all that YAML out, or say like, oh, I need a service and I need this. It's so high level, like the deploy script that I just showed you, that's like, and it has a bunch more features than I showed you actually. It's like, I don't know, 100 lines of Python. It's really basic. Most of the stuff was actually originally written in like Bash. So it lets you sort of, there's this thing knocking around in my head which says maybe Kubernetes is high enough level, and the next level up is always going to be kind of per organization. Everybody's going to do things a little differently. We use stage and we use prod and we use local dev. Other people do things differently. Maybe some people, when they want to test things, they stand up a whole new cluster and they test that and then they delete it and then they go to prod, or whatever they do, right? And all of those decisions are based on history and the market you're in and the dev team you have and the size you are and all that stuff. So the cool thing about Kubernetes is it gets you up enough that you can easily yourself build the thing that's special to you. And that's what we've been doing so far.
I think there'll be open source or not tools that will emerge to facilitate that.
Yeah.
It just happens to be very opinionated and grand, but
Right.
like I'm sure somebody will come up with the YAML
Yeah.
problem because this is heard often.
Yeah.
And,
Yeah. And
and
like,
I give you what is that Yo something that they create manually, and so I'm sure
Yeah.
someone's come up with a UI that'll generate the YAML for you.
and you know, like a lot of the deployment stuff, it's very early, but it's something that we've talked about open sourcing. But again, it's one of those things that once you use it, you have to agree with our opinions to a certain extent about like where you put configuration and how you deploy secrets and all of that stuff. So that's it for the talk. This is a link to the talk. If anybody wants to see these slides, they're up there. And I'm open to any other questions. Yeah?
How do you scale nodes?
It's a auto-scaling group inside Amazon. So you just go to AWS and in the console or the command line, or you can set up a CloudWatch thing and just say, I want more nodes. And it will stand up the nodes, and Cloud Init is configured to install all the Kubernetes node level things that it needs, and it's configured to know the IP address or addresses of the master. So you literally hit a button, and it creates a server, and in 15 minutes, you've got another node running.
How reliable is that in coordination with pod scaling? Because let's say, I guess your pod scaling is static, you always scale it to X amount, or is it dynamic that it'll scale to however much is needed to alleviate traffic throughput?
It's either way. So by default, it's static. You just say replicas 5, and it's static. But there's a resource called a horizontal pod autoscaler, and you can say, based on this metric, scale the pods, and it will. So when you stand up a new node, it doesn't really like take jobs, but as soon as it doesn't like steal jobs. So it won't be like, oh, I'm gonna go kill 20 pods so that everything's even. But next time somebody asks to use more resources, they'll almost certainly all go to that pod because it's empty.
But that depends on your schedule and policy, right?
Yeah,
and Kubernetes has so many ways to slice and dice. So
yeah, there's lots of like gears and knobs and switches to turn these things on and off. Everything's default for us, and it's working great. So we don't have a lot of compute-intensive workloads running here yet. We have, obviously, we're a video company. We have some compute-intensive workloads, and we have ported them over to Kubernetes, but we haven't run them inside our production cluster yet. That's another thing that I didn't have on a slide, but we've gotten several. Like, we haven't actually switched over to running them in production, but we've gotten several of our existing services running inside Kubernetes, and each one took between 10 minutes and an hour to port to Kubernetes. Same thing, we had like at least one thing that somebody had stood up in Heroku because they needed it done quickly, and because everything's environment variables and everything's like sort of packaged applications, it was just like you just had to write the YAML file and it just worked, which is pretty cool. It's if you're running like an application that expects to be running on a single giant bare metal box in a data center somewhere with a fixed IP address and some magic special IP tables configuration, you're probably not going to port it over to Kubernetes in an hour. But if you have an application that's already running inside AWS, you probably won't struggle to get it running inside Kubernetes. Once you kind of understand Docker or containers and how they work and what you're supposed to do and what you're not supposed to do, I guess is one thing that I would say. We kind of struggled when Docker was first coming out. Like we were like, oh, what if we like run Puppet inside Docker and then we get a Docker image of our app? And it's only like 10 gigs and it only takes 15 minutes to build because that's how long Puppet takes to run. That's not like the right way to do it. You really just want the app running. And then, like I said, a lot of the stuff that's Puppet's doing is sort of like, doesn't need to be done for every app. It only needs to be done for every node, and since an app and a node aren't the same thing anymore, you don't have to do it nearly as often. So I'm like way over time. So.
No, you're good, you're good.
No, it's great.
I know it's late. First of all, thanks everybody for coming. One more round of applause for our two speakers. That was awesome. If you guys have any questions, I'll shoot out my information. Would you guys mind if I shot y'all's out as well, just so everybody has it? Obviously, Vehicle on Twitter.
Links on either the.
Yeah, we'll do that.
posted a link to some of my stuff.
You could post that, yours.
Yeah, we'll definitely get that.
We've got the hashtag too. Couple things coming up. Container Days, October 14th, 15th October. KubeCon in November. And then who had mentioned deep learning? Was that you? Yeah, that's coming up too. So I'll send out. I think in a couple months we'll do it again sometime in November. Feel free to invite whoever, and then post if there's any questions. Just post on the message board. Cool. And anybody with wife and kids out here? Raise hands. Plenty of pizza left. Please take some. All right. Thanks.
Good job.
Hey man, thanks for having us and thanks for organizing. Yeah, thank you.
We'll do it again.
Randy, my answer is yes.
Yeah, so I'm just curious, obviously a small. 6 foot.
Yeah.
Oh, that's it. Yeah,
Which is kind of good at that.
Yeah.
Because it's bringing.
You've been here long. You've been here so long.
I guess I just
Yeah, so like what drew us was like we wanted to stop, like we didn't want to be.
The problem was.
The problem was
Thank you so much.
it was difficult for us to create. So it was difficult for us to start shoehorning new features into our existing services. Like we had probably 6 to 12 services, right? And anytime we wanted, they were all independently deployed. And anytime we wanted to like add a new feature, we were sort of like, well, we could write a new service, but if we do that, we need to go do Puppet and we need to go do this and we need to create databases and we need to back them up. And I'm just gonna find a place in this service to put it, right? And so like
Promote the monolith.
it promoted the monolith, so it like discouraged the programming practice. And it also, you know, like people, when we did need to go to Puppet, when we did need to, we knew that like we're running these nodes, so like we've got this, say we've got some service, and like mostly like 2 or 3 customers, and they're only in the US, so they're only using it like 9 to 5, Monday through Friday, like, so like, we always want 2 servers running, right? Or at least 2 instances running, right? Yeah, so it's like, yeah, like we don't want to turn the whole service off, but kind of the minimum viable thing is 2 smaller
But if they're
nodes.
combined, you get more.
Right, so there's some like offsetting in there that we like, and just sort of like operationally having some simpler. So now, right now, when you go look at our like older stack, like every node, like this node has Python, it has this, and this, and this for running this application, and this node has this. Yeah, and there's all these dependencies, and everything is like the node, like all the nodes with that run an app are the same, but those nodes aren't the same as the nodes that run a different app. They're close, but they're not the same. And so there's a lot of overhead in managing them. So this sort of says, okay, the nodes are this, they're all exactly the same, and you're after this higher level thing.
Well, because the nodes are cluster, they just run the cluster
Right,
hopping.
everything's homogeneous, and then, yeah, so.
I'm just having a really hard time, like, I get a good feeling this is the right now. It's just that I have, you know,
If all you have to do is give somebody like a Python virtual env and they will run it for you, you probably don't care how the performance, right?
Yeah, except that when things don't work, or environment stuff, you
Yeah.
get pulled in to figure it out.
And we're very much DevOps because we have no ops, we only have devs, so they all have to be DevOps.
Everybody.
In some way, you're like a tribute.
Contributes, or
Yeah.
you tend to have
No, everyone. I was the one, I happened to be, another dev and I happened to be the guys that grabbed the ticket, did the initial work, but,
What was the ticket? Was like, oh, let's.
the ticket was like, oh, well, no, the ticket was like, we need to create this new service, we really want it to be its own service, we're sick of like dealing with Puppet and provisioning servers, so let's figure out how to make it work for Kubernetes.
And how long did it take you? 2 weeks?
Yeah, sprint and a half, maybe 3 weeks. By the end of 3 weeks, we figured Kubernetes out, and we had a service with a health check running inside the cluster instead of AWS.
I was curious how you got Kubernetes plugin working with Sumo Logic on Fluentd, because I never got that shit working. And in fact, the Sumo Logic people never could get that working for me.
So what we do is we created a cloud collector inside Sumo Logic, and you get an API. And then
Using the syslog plugin instead of the regular Sumo Logic plugin?
that's not what we're doing. We're just using the Sumo Logic plugin. What we did was we took the YAML, we took the YAML for the Fluentd container, and then we took the actual Fluentd config file, and we deleted the exact Elasticsearch code, and we dropped in Sumo Logic code. And the one trick that we had to do, the one weird trick, is that Sumo Logic, the HTTP endpoint of the collector is a secret value. You don't want to give that out. So what we do is we have a secret and it has that value in it, and then inside the Docker file, we read that environment variable out, and then we run sed on the Fluentd config file to like replace a random token with the actual value, and then we launch Fluentd. And it's running as a daemon set.
Right, but all that Kubernetes metadata, like Sumo Logic doesn't have enough parameters that are parsable.
We send
so
JSON to Sumo Logic.
But they're able to make that searchable by default, or you must be doing some magic there in Sumo.
They're mostly, okay, so there's two ways to do it. If you're just running a search, you can, in Sumo Logic, you can say parse JSON, and it will actually parse JSON, and every single key turns into a field. And so if you have some nested thing, it'll be like key.value.0.value.
Okay.
You can't do that for the auto-indexing feature. You can't parse JSON and have it auto-index. So it slows your searches down. What we did is we wrote some regexes which can sort of like mostly auto-index for us. So when we have to run a quick search, we can do it. But like the message itself doesn't get auto-indexed very well. It's like looking for like, quote something, quote, colon, quote, not quote, end quote, and your message might have quotes in it, and then, so, for the names, for things like the namespace and the odd names and all that.
I just went with Scalar. You can run your own parser basically.
Yeah, we had Sumo. I was the one that took Sumo. We actually did used to have a DevOps. That's cool. Guy who was more ops focused, and he had used Sumo before, and he evaluated Sumo.
So it's cloud.
No, you can send from anywhere.
So there's a collector. It's a SaaS thing, yeah.
Basically, was it Netflix is their page selected by Netflix uses that. So that is.
They're like.
Yeah, they went to.
I remember the first.
Yeah, I mean, they. Most of the time, searches are fast, monitors work.
So Sumo Logic is equivalent to.
It's sort of like Kibana on top of Elasticsearch.
In your case, it's on top of Fluent.
Fluent streams logs into them.
There's a collector and an aggregator basically. Fluent is the collector and Sumo is the aggregator.
And the normal way is you run a collector locally, and it aggregates and ships things off. And it's like they wrote it. But they have a way of just like using Fluent or any other log.
What's your log stash?
Sumo stores the data and searching.
The Elasticsearch.
Elasticsearch and like Kibana, and then Fluentd watches the logs and like log sessions. And Fluentd is just like we literally like copy pasted, we deleted stuff. That's awesome. Scans them, and then we.
Why did you? Because I thought Elk was it just two over.
Kubernetes. I don't know why Kubernetes.
Deploy that.
Fluentd over.
Fluentd is a lot more lightweight.
It is Ruby.
It's open source because it's specialized.
And it's got a lot of.
Both they are, but the support, right?
No, there are parts of it that are proprietary now. Fluentd is fully open source.
I mean, you could write a proprietary plugin for it, I suppose.
It's MIT license.
Nobody does. Yeah.
I'm sure, you know what I mean?
Yeah, I'm not sure.
No, that'd be cool.
It's, there are a lot of good reasons. And also there's a Docker log.
Yeah. Oh, we gotta go? You guys, I think we're gonna go get some of the drink. Where?
Hey,
I don't
if
know.
y'all want, take some pizza, please.
I have pizza in the fridge, I'm sorry.
It's all great.
What's the destination?
Oh, where do you guys wanna go?
I usually say Chicago House. Yeah, so.
Sucks. We didn't move it.
Yeah, why don't you go there and grab a beer before this,
Yeah,
Looks good.
Cool. You want any like water or Coca-Cola?
I'm okay.
I knew it was too much, but I just didn't want to have enough.
Did you wanna get rid of a fuse just so it closes, or?
No, yeah, actually, yeah, let me. I don't like software.
Seemed like a good turnout.
Yeah, I met like 20 some people, like, I mean, not, the 60 people actually, I knew it wouldn't get
Yeah.
60 people, but like, for the first one, I've been to other ones that like, people ain't going to for a while, there's only been like 15 people.
Right, yeah.
I'm not a tech guy, so it's fucking brutal for me, but I play the part. Alright, brother, thanks again, man.
Well, did you, are you gonna take this out that elevator?